Okay, let's talk about reflection. So remember, reflection is a little different. It's not, light isn't going through the material, it's actually bouncing off the surface. So when you look in a mirror that's nice and a normal mirror that reflects exactly what you see, you as you see, it doesn't make you bigger or smaller or change your shape or anything. What's happening is, so if we draw a normal to the surface of the mirror, the angle of incidence of every light ray is equal to the angle of reflection. And so remember, we always measure these angles relative to that imaginary normal. So I is equal to R here. And for a specular reflection, where you get the exact, image of what you're looking of the object, all of those rays of light that are hitting that surface are bouncing off, following this law of reflection that the angle of I equals angle R, and they're parallel to each other. But when you have a surface that's not exactly even, then some of those reflected rays will bounce off and you'll get some interference, and so the image won't look good, right? It'll be fuzzy. So think about, like, sometimes you see like a pseudo image on the surface of a table, but it's not an exact image of what you're looking at, and that's because of diffuse reflection. So the law of reflection says that the angle of incidence is equal to the angle of reflection. So in this case, the angle of reflection is indeed I. It turns out that all images that you see when you look at something that is being formed in a flat mirror are virtual images. If you think about it, you can draw rays of light from different points. So for the top of this ray, this first ray, it bounces, it hits, and then it bounces off using the law of reflection. Actually, it goes this way, and then it goes like this. So we're seeing this. And then notice that the other, at the bottom of the object here, it bounces off, and then it bounces back to your eye. But the rays that are actually hitting, actually forming the image, are projections of those rays behind the mirror. So in this case, the images are always going to be virtual, and they're always flipped left to right, and that's because of the geometry of this, right? So when we use the Lensmaker's equation, we can use 1 over F equals 1 over di plus 1 over dou when we talk about mirrors. But this equation really only applies to curved mirrors. Mirrors that are flat like this are always going to produce virtual images. And if the object is, 5 meters in front of the mirror, the image is going to be negative 5 meters. Now, remember when we talked about lenses, negative meant it was on the same side. But see, what's different here is that the reflected rays that could form a real image are going to be on the same side. So there's a difference. Because mirrors reflect light and they don't refract light, let light go through them, the rules are going to be opposite, okay, for when di is negative and when it is positive. So converging mirrors, they are going to have the same kind of rules. We can form real images and we can form virtual images, but a converging mirror is not called a convex. It is actually the inside of the cave. It's called a concave mirror. So a concave mirror converges light. A concave lens diverges light. So just remember that the names and what they do are opposite because they do opposite things to light. And since it is converging, F is going to be positive. That's our main rule that always stays the same. So the focus is here, and it happens to be always half of the center of curvature. So if you think about this lens as being part of a big circle, and that circle has a center, F is always half of that. So if the center of curvature is 20 centimeters, F is 10 centimeters. And if it's a converging mirror, then F is positive 20 centimeters. When the object is greater than F, you're going to get a real image form. But in this case, that's on the same side as the object. And die will be positive, and magnification, because it's a real image, will be negative because it will be inverted. When F is object is less than F, what happens is that the reflected rays, this ray and this ray, never, ever, ever meet on the same side. So you can never get a real image to form in this situation. They form on the opposite side. So it forms on the opposite side. So die will be negative because it is virtual. It cannot be projected. And it will be magnified. So if you had a concave mirror with a radius of curvature of 20 centimeters, F is going to be 10 centimeters. And it's used to view an ant that is 100 centimeters away. So DO is 100 centimeters away. And we want to find the image. Die in M. 1 over die is going to be equal to 1 over F minus 1 over 100. So 1 over 10 minus 100, 1 over equals 0.09, and take the inverse of that. It's going to be 11.1. So die is going to be 11.1 centimeters, which is a real image. And since we're talking about mirrors, it's on the same side. And we should expect it to be upside down. So when we find negative die all over DO, negative 11.1 divided by 100 is going to be negative 0.111. So the magnification of this is negative, which means that it's inverted. Real images are always inverted. If we have a concave mirror with a radius of curvature of 10 centimeters, its focal point is 20 centimeters divided by 2, or 10 centimeters. And now we're going to view something that is, let's make this 5 centimeters away. So die and M are what we're going to look for. 1 over die equals 1 over 10 minus 1 over 5. 1 inverse minus 5 inverse equals negative 0.1, and take the inverse of that. And we get die is equal to negative 10 centimeters. Now, which means that it is virtual, and it will form on the opposite side of the mirror. And negative die over DO is going to be negative 10 centimeters all over 5 centimeters, which is 2. So it's virtual, forms on the opposite side from the object, and it is upright, and it's 2 times bigger.